Hi, everyone. Welcome to the Earth Science Classroom, the classroom dedicated to everything Earth science, geology, atmospheric science, oceanography, atmospheric science, a little bit of astronomy. So the whole kind of subject in one channel. So, guys, today we're looking at the East African Rift Valley system and looking at the Great Lakes. So we've done some videos on the different branches. The Eastern branch, which is the longer one, which includes the main Ethiopian Rift going down through the Kenyan Rift and down in Tanzania, and the Western branch, which has a lot of the deeper lakes and all the half-graben formations around the Tanzanian Craton and the East African Dome. So we kind of the point where we are looking at just the lakes in particular. Now, I've drawn this kind of table up, as you can see on the right-hand side, where it's kind of listed all the lakes in order of size. So the square kilometers or kilometers, largest first, which is Lake Victoria, down to Lake Natron, which is one of the smallest, and Lake George. Also, you can see the size difference as well. We can discuss that, and some other details like the depth of each lake, both the average and max, the pH range, which is very important, which links back to our soda lakes and the high alkalinity caused by the various features and processes going into the lakes. In particular, they are the closed lakes. They only get fed in through certain rivers, but the only way they lose water is through evaporation. And then obviously the elevation itself, which again comes back to the physical geomorphology of each lake. So come join me now for the rundown. So if you look in general, you've got some major lakes. I mean, there's some articles and journals and textbooks say that there are, 8 Great Lakes, or some say 7. So you can include as many as you really want. I mean, the main ones are on the map right here with Lake Victoria, Lake Albert, Lake Edward, Lake Kivu, and here Lake Tanganyika, Lake Wakwa, and Lake Malawi, or otherwise called Mayasi. So these lakes, you can also add in Mwaru right there, Lake Natron right there on the northern Tanzanian border with Kenya, Lake Turkana, which is the only lake in the eastern branch, and it's kind of like in that middle section between the two domes, the Ethiopian dome and the East African dome or Kenyan dome, and it sits really at a really high elevation. As you can see here, it's over 1,000 feet high, but still in between the two domes. Now, we can discuss Lake Victoria first because it's the biggest one and probably the most well known. So Lake Victoria is the biggest of the Great Lakes in this East African Rift Valley system. It is a massive lake. It is shared by 3 main countries, Kenya, Tanzania, and Uganda, and it has an average depth of around 40 meters, maximum depth of 84. So it's not on the deep side compared to other ones. It's more like in the middle range of depth. Now, Victoria, like most of these lakes, is highly stratified, has stratification, which means that there are layers, distinct layers based on temperature and density within the lake. So the top layer has the majority of the nutrients and the oxygen. As you go down deeper, there's no real mixing. And occasionally the wind will change through seasonal changes, but because it's right smack over the equator, it's pretty consistent winds, consistent climate, very sub-arid climate, and of course it's very high elevation. It's over 1,000 meters elevation. So I mean it's very high up on the Tanzanian Craton. So and it's bordered by these large mountains of the half grabens of the depression, and is very stable lake, very stable lake, and been around for about 400,000 years since the Western uplift, and really has a thick amount of what's called lacustrine deposits at the bottom, up to 60 meters thick of ancient sedimentary deposits at the bottom of the lake. So extremely layered, and these are great for fossils, paleontology, dating of various index fossils, and has a great way of showing the lake's history as well. So it's also very important because it is one of the reservoirs of the Upper Nile Basin, which is going to feed into the Nile watershed, the Nile River, and flow obviously up through into Egypt. Also, Lake Victoria is officially the third largest lake on the planet. Only Lake Superior in the United States, in Canada, and Lake, or not lake, but the Caspian Sea are two lakes that are larger. But Lake Victoria is a seriously large lake, even though on this map being so big, it doesn't seem as impressive. But because Africa is such a large continent, it kind of like gets basically lost sometimes. But it is the third largest on the planet. All right, so now we get on to Lake Tanganyika. So now it's over here. There we go. So this immensely long river is the second longest lake on the planet. Now, it is part of the eastern branch. So Lake Victoria, as mentioned earlier, was kind of like in between the two branches. So even though it's high elevation, it's still like in between, more like a catchment area, more of a very large puddle, basically accumulating of water coming off the sides of the Rift Valley. However, Tanganyika is literally made over the rift. There's the basin, and then most of that basin is full of water and creates Lake Tanganyika. So it is the second longest lake in the world, and it is the second deepest lake in the world as well. This thing is insanely deep. Only lake that actually beats it out is Lake Baikal, which is in Russia, which also is another rift valley, which we'll get onto in a different video later on. But it's the second deepest. It is insanely deep. It is 570 meters on average. Compare that to Lake Victoria, which is 40. This is 570, and the deepest part is 1,470 meters deep. It's insanely deep, and the elevation is 770 meters, which is here, and also you get your first, or basically it's the first alkaline lake. An alkaline lake has to be around, or a soda lake or saline lake has to be around pH 9 or above in alkalinity to be classified. So Lake Victoria is pretty much in the range of a normal freshwater lake. Lake Tanganyika is not. It is more alkaline due to the processes of volcanic action, weather and erosion processes, and the amounts of evaporation. And the depth is highly stratified layers in the lake, and therefore it can have large accumulations of CO2 built up at the bottom of the lake. So as it is part of the the western branch of the rift system, it does have these lovely half gravens kind of forming on the borders, on the boundaries of the Lake Tanganyika on the western side and the eastern side, and it's kind of that very large V shape profile. And what you have is this very deep lake. You also have about 2,000 species that are just from this lake because it's closed off. Rivers do feed it, but the only way it loses water is through evaporation. So this is also an area where they have 5 kilometers of those ancient sediment beds at the bottom. Again, great place to look at the age and history of the lake. And this lake is a lot older. It is presumed to be between 9 and 12 million years old. Compare that to Lake Victoria, which is 400,000. So Lake Tanganyika is one of those ancient lakes, one of 20 ancient lakes on Earth, which were formed millions of years ago. So the animals and plants that are indigenous to this area have a long time to diversify and specialize through natural selection, through evolution in this lake. All right, so we've done Victoria, Lake Tanganyika. Let's move on to Lake Malawi. Again, a very long, slender rift lake. Basin is a rift basin with the half gravens, and the lake basically very deep. Malawi is obviously deep, but not as deep as Lake Tanganyika, 292 meters average, or a max depth of 72 meters. So you can see geologically that there's an increased rift over here in this area of Lake Tanganyika, in the countries of western Tanzania, um, Burundi, and Rwanda, but over down here with Malawi, Mozambique, and southern Tanzania, Lake Malawi shows that there is decreased rifting due to the depth not being as deep as Tanganyika. However, specialized ecology, deep sediments, and you're looking at also that middle range pH like Lake Victoria. So again, you've got that similar processes happening. And again, it's not as high in elevation, so it's low in elevation. So you're kind of coming off the East African dome and down into more lower elevations, down to Mozambique and southern Malawi. All right, next lake, looking at the northern part of this map, Lake Turkana. Now, this is in Turkana Depression. It is, again, located between the East African Dome, which starts around Lake Kiaga, Lake Albertine. There we go. And you've got the branching off of the western branch over here, the eastern branch down here, goes down through Kenya into Tanzania and basically east of Lake Victoria and through Lake Natron. So Lake Turkana is, again, another very long, slender rift lake. It is in that basin between the northern Ethiopian dome and the southern East African dome, and sits kind of like at a decent elevation, okay? Decent elevation of over 1,000 feet or 360 meters. It does have a really high pH, though. It has a pH of 9.3 and 9.4, which is definitely alkaline and definitely solar lake, and is, again, it's a large drop off. So you see that Lake Victoria is obviously a very large lake. Lake Victoria, Lake Tanganyika, Lake Nile. You can obviously see through the map that they are larger bodies of water. Now we're getting into the realm of they're still Great Lakes. However, the size difference decreases dramatically. Lake Turkana is a lot smaller at only 6,500 square kilometers. And it's very shallow comparatively to Lake Tanganyika and Lake Malawi of 30 meters average to 109 meters in max depth. Only in certain areas is that max depth achieved. So with this being said, there's a kind of pattern with the smaller lakes. Up goes the pH, up goes the alkalinity, and the small lakes also aren't as deep. Lake Tanganyika, Lake Malawi are very unique in the fact that they sit right over the rift, whereas the other lakes kind of don't have that same situation. So we have, next one is the northernmost one of the western branch, Lake Albert, which is what they call this whole western branch is the Albertine Rift. And this was named after an English royalty. All right. And basically, this is a smaller lake. All right. It's only 5,299 square kilometers. It's kind of shallow, on the shallow side. So on the max depth, only 51 meters, but it has an average pH of around 9. So again, it's very saline, and it has basically an average elevation for this area of 615 meters. So these are all high elevation lakes. It's all, as you can see, around the equator. So the conditions are extremely humid, arid, humid basically based on the rainfall is mostly seasonal, but very, very hot, arid conditions generally, and also plus the elevation as well. You're going to get various conditions all year round. And because they're usually sheltered by the Rift Valley border, and that also causes these lakes to be sheltered and closed due to that. So Albert is famous because it goes into what's called the White Nile, which is mostly made of clay. So that's why it's called white, and also the Blue Nile. So the White and Blue Nile kind of connect to form the Nile normally, as you know it, through Egypt, and also has very deep lacustrine sediments and deposits, again, like Victoria and also like Tanganyika. And it has two or three main rivers flow into it, and a main source of losing water through evaporation, and has basically gone through four stages of development over the last 17 million years as the western branch has torn itself apart, and that rift has become larger. It's in different stages of development, leading to what it is currently or present day. All right, so in my mind, leaving the best to last. I mean, these two lakes are kind of like famous. Lake Victoria obviously is huge, third biggest. Lake Tanganyika is the sixth biggest and a very long lake, but very extremely deep, second deepest in the world. However, Lake Kivu, right here on the border of Rwanda and the DRC, Democratic Republic of Congo. Lake Kivu, and also Lake Natron. Now, Lake Natron has been the case study of many documentaries, many shows about the severe or even dangerous nature of these lakes. Now, Lake Natron, in particular, has extremely high pH of around 10.5 pH, or up to occasionally up to 12. Now, this is such a alkaline condition or environment that only certain birds and animals can actually exist. They've seen about 2.5 million pink flamingos kind of use it as their habitat, their home. However, a lot of these animals do succumb to the extreme conditions of the salinity and the mineral deposits and iron deposits, and actually don't survive. It could kill these animals. Lake Kivu is a little different. Lake Kivu is a smaller, only 2,200 square kilometer lake. However, it is rather deep for its size. So it's on average 220 meters deep, which is pretty deep, near as deep as Lake Malawi, and it does have a max depth of 407 meters. So it's very small in size but deep. So that actually causes its own set of problems, and it can actually cause a limnic gas eruptions. Basically, the lake could explode. Now, there's been 2 times in Cameroon where there's been eruptions of large volumes of CO2 and CH4 methane gas that have bubbled up from deep below these deep, small lakes. And because of the CO2 being heavier, methane being heavier than air, than the nitrogen and oxygen, it's heavier, it's going to stay at the surface and kind of drift like a very thick, dense cloud of air that obviously does not contain oxygen. It's kind of pushed away by this CO2 and CH4, and it actually can acidificate and basically kill any animals or people that are around the edge of the lake or the coastline of the lake. And that's happened twice in Cameroon in recent history, and it's silent and deadly. Basically, it's hard to predict, and once it happens, you have to get out of the way, basically. So Lake Kivu has been researched as a lake that possibly could do the same thing in the near future, where it has a dangerous buildup of CO2 at the bottom due to its lake being stratified and stratification, where there's no mixing, where CO2 gets trapped at the bottom through various volcanic and magmatic processes, adding the CO2 into the deep water, and also from the weathering and erosion processes of the lakes and the rivers flowing in. So there are set conditions that cause the CO2 and methane to build up as like a large gas pressure, and once it gets too high, pressure equalizes, and the gas gets pushed up out of the lake and is very dangerous. We'll do another video on that as well. And Lake Natron is exceedingly dangerous just to be around it, let alone in the future. So these are awesome lakes. Again, part of the Great African Rift System, Great Lake System. And yeah, I hope you guys enjoyed the video. Please subscribe if you haven't subscribed, and look forward to doing more videos on this topic.